Hello, this is Mr. G. In our last video, we talked about how we can factor trinomials with a lead coefficient other than 1 by using a method I called the stupid sentence. As we were learning that method, I mentioned that we always need to look for a GCF and divide it out before we can use the stupid sentence, but I didn't explain why. In this video, we're going to answer that question by looking at just one example. Factor 6x squared plus 14x plus 4. We're going to do this problem two different ways. We'll see what happens when we remember to factor a GCF, and then we'll see how the answer changes if we forget to factor a GCF. Let's start with remembering a GCF. If we remember to look for a GCF, we see that we can divide each of our terms by 2. When we divide that 2 in front, we get 2 times 6x squared divided by 2 is 3x squared, 14x divided by 2 is 7x, and 4 divided by 2 is 2. At this point, we're done with the GCF. This 2 cannot be factored anymore, so I'm going to write it on our answer line. Our final answer will be 2 times something. We don't know what that something is yet because we still need to check if this trinomial 3x squared plus 7x plus 2 is factorable. Since we've already written our GCF of 2 on our answer line, we can sort of ignore it and just focus on our trinomial. So I'm going to write 3x squared plus 7x plus 2 on its own to make our work a little neater. To factor this trinomial, we're going to need to use the stupid sentence because the lead coefficient is not 1, we see a 3 there. So we write out our checklist. Most frogs don't say much. M is multiply, so we multiply our lead coefficient of 3 by the third term of 2. That makes our new trinomial x squared plus 7x plus 6. Multiplying is all done, so we can check that off. F stands for factor, so now we have to factor our new trinomial, which means it's going to be 2 binomials that both start with x, and we need 2 numbers that multiply to give us 6 and combine to give us 7. The 2 numbers that fit that pattern are 6 and 1, so we write x plus 6 times x plus 1. All done factoring, so we check off that step. Now it's time to move on to D, which is divide. In this step, we need to divide our 2 numbers, 6 and 1, by the original lead coefficient that we used in our first step, our multiply step. The lead coefficient we multiplied by was 3, so that's what we have to divide our 2 numbers by. We get 6 divided by 3 and 1 divided by 3. We're done with our division, so we move on to S, which is simplify, and we just simplify our 2 fractions. We get x plus 6 over 3 becomes 2, times x plus 1 over 3. We can't simplify that fraction anymore, so it's just x plus 1 over 3. All done simplifying, so now we just have to move on to our last step, M for move. In this step, we move any denominator to the front of the binomials. There's no denominator to move in x plus 2, so we leave it as x plus 2. But in the second binomial, we see a denominator of 3. That gets moved in front and becomes 3x plus 1. We can check off our last step, which means we're done using the stupid sentence. Now all we have to do is take these 2 binomials and write them in our final answer line. That makes our final answer 2 times x plus 2 times 3x plus 1. And we can check this answer by distributing. There's a few different ways we can distribute here. I'm going to start by distributing the 2 binomials. That means we don't do anything with the 2 yet, so it becomes 2 times. Now let's do some distributing. X times 3x becomes 3x squared. X times 1 becomes 1x. 2 times 3x becomes 6x, and 2 times 1 becomes 2. Then we just combine our like terms of 6x and 1x to get 7x. And now for our last step, we just have to distribute that 2 into the trinomial. 2 times 3x squared becomes 6x squared, 2 times 7x becomes 14x, and 2 times 2 becomes 4. We can see we made it all the way back to our original trinomial of 6x squared plus 14x plus 4. We can be pretty sure this answer is correct then. But what if we forgot to look for a GCF? Let's see if that changes our answer. If we forget to look for a GCF first, we just see a lead coefficient of 6, which isn't 1, so we think, okay, we've got to use the stupid sentence. Then we write out our checklist, most frogs don't say much, and follow the steps. M stands for multiply, so we multiply our lead coefficient of 6 by the third term of 4. And that makes our new trinomial x squared plus 14x plus 24. All done multiplying. Now we move on to our factor step. So now we just factor this trinomial into 2 binomials. We know that both start with x, and we're looking for 2 numbers that multiply to get to 24 and combine to get to 14. Two numbers that fit that would be 12 and 2, so we write x plus 12 times x plus 2. We can check off factor and move on to our divide step. So we divide our two numbers of 12 and 2 by the original lead coefficient that we multiplied. This time the lead coefficient we multiplied was the 6, so we divide 12 and 2 both by 6. Done with dividing, so we move on to simplify. So we just see if we can simplify either of our fractions, and we can simplify both this time. First, we get x plus 12 over 6 becomes 2, times x plus 2 over 6 becomes 1/3. Check off simplify and move on to our last step, which is move. So we move any denominator to the front of the binomial. No denominator to move in the first binomial, that's just x plus 2. And in the second binomial, we see a denominator of 3 that gets moved in front to make 3x plus 1. We can check off our last step, which means our final answer is x plus 2 times 3x plus 1. But that's not the answer we got when we remembered to factor a GCF. Let's look at our two answers together. The answers are almost identical. They both have x plus 2, and they both have 3x plus 1, but only the first answer has the factor of 2. We already checked our first answer, so we know that's correct, which means our second answer must be wrong. And that makes sense if you think about it, because x plus 2 times 3x plus 1, we distributed that out already, and that gave us 3x squared plus 7x plus 2. Not 6x squared plus 14x plus 4. So this equal sign needs to be changed to say not equal. I hope you see why it's so important to divide out a GCF before we use the stupid sentence. If we don't, that GCF will disappear, it won't be in our final answer, and that'll make our answer wrong. So if you're going to use the stupid sentence, always look for a GCF first. Hopefully this made sense. If you have questions, by all means put them in the comments below. And until next time, enjoy the rest of your day.